engineering faculty should know the electrical aspects of their automation system. Electronics people should know electrical aspects. Electrical core engineering people, they should see how easy it is to design their control panels, how do they wire the system, and with this, how one can save huge cost in testing, validation, how we can save our important lives, because many of the times it is accidental issues. When we talk about three-phase connection, single phase connection, it is difficult for students to experiment without experience. So for them, virtual experience is the ideal thing. They can really test, they can experiment, and with this they can build their confidence, show to the faculty that whether wiring, whatever wiring they have done, it is correct or not. So we have seen power of simulation. You must have used MATLAB, ETAP, Simulink, CAD product. So today we want to showcase you that how simulation can play a vital role in electrical technologies. So I can say many of your engineering people, even I have seen ITI people also have joined it. And today, the most demanding trade in ITI is electrician. Why? Because there is a huge demand for electrician people. In today's automation era, these people are highly paid, highly required. Even engineering students also, we have seen huge demands for PLC wiring and PLC automation system. So understand that how we are going to use this software to design your electrical system, to design your motor actuation system, home wiring, your PLC wiring, and you would amazed to know that we have more than 3-4 PLCs under this software, that you will feel as if you are wiring that PLC by your own. So in and all, it is very important to know the aspects of electrical engineering when we talk about automation and robotics. Why I'm saying you, I'm giving you a very common example. Today is the age of artificial intelligence, and we have developed software for leopard detection because it is a huge society problem. And for that, we have used GPU, graphical processor unit. And for that GPU, we wanted to connect our three-phase connection line to that GPU. So how do we do that? How we have used MCBs, and then how we have converted that AC source into DC source, how we have connected that GPU. Then again, siren was supposed to generate 120 decibel noise. So ultimately, how we have used how we have used relay on GPU. So all these, without electrical, it would have not been possible. So you use AI, you use smart car, wherever you go, you use robotics automation. You need to know basic aspects of electrical technology, and this is how in today's webinar you will be enjoying that thorough wiring system. How do we use MCBs? How do we put motors? Star delta connection, AC motor, DC motor, control panel designing. Everything is full of knowledge, and most of you will be able to save crores of your rupees. Some people might be wanting to develop their laboratories in electrical technologies. So how do they do that? You must have your existing computer lab. So instead of putting a lot of cost on hardware, how can you use existing software or automation studio software, electrical technologies, and boost your knowledge in electrical aspects of automation. So I am Sunil Chore, CMD, SimuSoft Technologies. I have been working in this sector for more than 2.5 decades now. With me, my team is there. Chaitanya Gaikwad, he is electrical engineer, and Automation Studio is a product from FAMIC Canada, and it is sold in more than 110 countries. It is industry's very popular product. It is not only used for only hydraulic, pneumatics, robotics, but electrical, PLC, automation, HMI. So everything under this automation, the entire studio, it is full of more than 5,000 components library. So the way you put your Rangoli, similarly, you have to use component of your choice. You want switch, you want sensors, you want PLC, you want wire, whatever thing you need, you have to just drag that, drop, and build your circuit of your choice. So right from second year engineering, you want to start with Ohm's law, Kirchhoff's law, star delta, then transformer circuit, AC/DC circuits, everything you have. You will save crores of rupees in your electrical instruments. You want to use ammeter, voltmeter, CRO. So everything is virtual. You have to just drag, drop, put that wire there and measure the current, measure the voltage, see the waveforms of currents, voltage, and complete your practical in a smart way on computer. So before I start to actually, taking a hands-on on Automation Studio, we want to show you that how this entire electrical automation, PLC, we have clubbed together and we have established India's first Industry 4.0 Center of Excellence in Vidya Pratishthan Engineering College, Baramati. That Center of Excellence I would like to show you so that you can see that how electrical aspects are very important in robotic automation. So I'll request my colleague to show you that real Industry 4.0 Center of Excellence which we have built in Baramati, so that you can have a glimpse of that, and later on we can start on actual software part. Products. Honorable Sharad Pawar sir had come to see the review of this center after 1 year, and this is the self-assembled drone. So flower dropping test we did.
Of human leopard conflict. So
this was the demonstration of that AI leopard detection software which I was talking about.
Under the guidance of Honorable Pratap Pawar, we could achieve this phenomenal dream. Pilot project we have done in Junnar Forest Division. Second project we are implementing in Buldana Forest Division. And almost our test is done and we are on the verge of implementing it.
So this was AI project we had done. Then these all are
when I was sent to Japan by Honorable Pratap Pawar sir, I saw that such a product is there.
Machining product.
It is a startup support. So if you see, this is the 5-axis and 4-axis machining done. So it is sold 1.5 lakhs yen in Japan. And we are selling it here in 25,000 rupees. So if you can see, these are 1 crore worth of machines.
VMC and CNC we are using industrial grade
mass production.
so that people will have
and some kind of aesthetics.
real industry experience at Center of Excellence.
Especially whenever leopard attack to this neck. This is the latest one. So anyone can get
whenever leopard
like
attack
so
from
whenever
backside,
you do any farm work,
you will save your life.
Your fear. आम्ही इंडस्ट्री 4.0 का म्हणलं इंडस्ट्रीची पहिली रेव्होल्यूशन झाली जेव्हा जेम्स वेबनी वापरायचं इंजिन आणलं त्याच्यानंतर इलेक्ट्रिसिटी आली 1858 आणि मग ह्या सगळ्या मेकॅनिकल यंत्राला इलेक्ट्रिसिटीची जोड मिळाली नंतर 100 वर्षांनी कॉम्प्युटर आले आणि आता इंटरनेट म्हणजे आता वायरलेस आता तुम्ही ही सगळी जी यंत्र पाहताय ना सर ही सगळी वायरलेस म्हणजे आता ह्या तुम्हाला रोबोट यू कॅन सी युअर प्रोडक्शन ऑन युअर फिंगर टिप्स
for audio system we have joined each other for Siemens S7-1200 PLCs.
In Japan, I saw
and SCADA is used, so everything is electrically wired properly. And
robotics automation वरती नुसती
in this electrical concept was very important.
भारताची पहिली महासत्ता आपण होऊ शकतो 50 कंपन्या आतापर्यंत इथे येऊन गेल्या वेगवेगळ्या राष्ट्राची लोक इथे येऊन गेली आणि महाराष्ट्र गव्हर्नमेंट हे मॉडेल आता रिप्लिकेट करते तर आपल्याला घर बसल्या मोबाईल वरती आपल्या खताचं प्रमाण किती आहे
IoT based project for fertigation and irrigation.
किती आहे हे सगळं कळणार पाणी नियंत्रण कळणार आणि हे सगळं इंटरनेटद्वारे आणि शेतकऱ्यांना नेकबेलचे वाटप सुरू केले बागान टमाट्याच्या बागांमध्ये जाऊन सांगतायत लोकांचे आम्ही फीडबॅक घेतले कशा पद्धतीने लोक सुरक्षित भावना निर्माण झाली आहे एका फक्त प्लास्टिकच्या बेल्टमुळे आता इथं इनबिल्ट कॅमेऱ्यांनी त्या ड्रोनचे
Mandar, Mandar,
Yes, sir.
uh, can you show that on your screen, our system?
Yeah, I can. Yes. We will connect on smartphone, then we can show
Yes,
easily.
yes, yes. See, why I want to show you that how electrical systems we can use for understanding this automation system. So just now what in center of excellence which we have shown you is just to let you know that how automation is built and how do we take these students and then train them, and we will now showcase you that how exactly electrical things are very important to know that systems. So yes, Chaitanya, please show.
Yes, sir. We are getting connected. Just a second.
Yeah, I just wanted you to show us S7 1200 on robot Scala.
Okay. होता laptop or
So please show them that how robotic system we have uh, and how that electrical part is very crucial to know that.
So here we have an electronic system. So in which PLCs are included, MCBs are included, then two relay cards are included, then SMPS is there, then Ethernet hub is there, then IO card is there for sensor and actuator for reading the sensor data and actuating the actuators. Then we have an MCBs over here. So after that we have an contactors, relay cards, motor driver, PWM motor driver included in the SCARA robot panel.
Okay, so this is a robotic system, and to know, to just let you know that this entire robotic system, what, how do we connect with sensors and PLC? You need to know control panel and then wiring. So it is very crucial for you people to understand the role of electrical technologies in building automation system. So we will start with presentation, actual presentation, that how exactly it can be done, how to drag and drop that electrical components and build your actual electrical system. So we'll start up with uh, basic electrical circuit. Before that, I will request Chaitanya to take over.
Okay, thank you, sir. So myself, Chaitanya Gaikwad, and I am as an application engineer in SimuSoft Technologies and looking into the this software automation studio electrical part and automation part. So today we are just I'll share my screen. Okay. So we will start with the basic introduction with the automation studio software. As this software is a multidisciplinary software including hydraulic, pneumatics, uh, electrical, and automation. Okay, so this is the basic interface of our automation studio software. We on the top side we have different tabs for different documents, BOM history, direct links, simulation option, different simulation options, fluids and tools. Then on the our left hand side we have a very large different components library by which we can create different circuits. Okay, so today we are going to see the powerful electrical module of automation studio software which helps in designing, simulating, and learning the electrical concepts very easily. So firstly we I'll show you the different libraries which we have in this software. So I will start with the different hydraulics components, all which we required for hydraulics and pneumatic circuits. Then we have different drives and transmission elements. Then we have different proportional control elements. We have the different standards of electrical control. Now which different standards? So I have IEC standard based, GIC standard based, NEMA standard based. So these are the different international standards according to which the components are being designed, and based on which we perform the different circuits and all. So IEC, which is like International Electrotechnical Commission standard, NEMA for National Electrical Engineering Manufacturing Association. So we have the different standard components. Having according to the standards, we have the different types of power supplies, different symbols, and all. Okay, so here in this software we have different PLCs. Now we don't have only a standard PLC. This software contains a large number of, so if I have to learn Allen Bradley, Siemens, and Mitsubishi PLC, I don't have to purchase all of them differently. In this software I can learn all of them very easily. So the cost of my multiple to learn multiple hardwares and their connections and all, I can learn all of them and connect all of them in this individual software only. So we have LS Electric, Siemens, Allen Bradley, and different. Then coming towards the electrotechnical and NEMA standards. So in this sub category, we have the all the required components and the parts which we required for our electrical circuits. So it continues from like basic AC DC circuits to the three phase circuits, different. If you have to make an different motor starter circuit, it with automation means I have to connect my all the electrical circuit with different uh, um, hydraulics and pneumatic circuit. I can connect and control them with my PLC circuit, different HMI logics and all. So hello. So now, firstly, I'll show you how easily it is. As sir have told you, is just like our rangoli, we have to just connect the dots and complete our circuit and simulate it, analyze it, and measure the different parameters. Okay. So firstly, I'll show you the simple Ohm's law, how we can make and demonstrate the Ohm's law. So first of all, we have a large library in electrical domain like electrotechnical IEC. I have lines and connections. In this, I have different like connectors, junctions, links, terminals, and all. So below that, we have a control library. In control library, I have all the control components like fuses, holders, and just not a single fuse and holder. I have the all the types and which I have like this is my single pole plus neutral, two pole for two phases, three phase disconnectors and all. Then I have protection relays, relay contacts, then different types of relay contacts for NO contacts, NC contacts, auxiliary contacts, push button, brake contacts and all. I have very vast library. Then comes to the switches. Now, for as of we know the industrial control, we start with the push buttons, pull switches, light emitter switches, mushroom switch, key locks, toggle switches, multi-position switches. Then the different relay contacts for to break and make contacts. Then we have the different sensors, level, pressure, flow, vacuum, temperature. Then different proximities switches and also. Now a different contactor coil, signaling coil. So we have each many components which we required differently for a different circuit. Now, and then a power library. Now in this power library, we have all the power components which we can say. We start with the energy sources. So in this, I have different battery sources, right? Starting with 12 volt, 24 volt, 40 volt, and these are all we all the parameters and modify. I can modify them. Just like if I have taken a 12 volt library, I can change it to 24 volt, 30 volt, and all as per my condition and as per my application. So here I have an option in my documents to select the different document for different library. Like I have a standard diagram for hydraulics, pneumatics, electrotechnical diagram for my electrical circuits, one line diagrams, then ladder diagrams and all. So I will take an one default circuit which will allow me for IEC and NEMA both standards of components to make this circuit. So from battery sources, I will take one energy source.
Make it bigger.
Yes, sir. Just a second. And so just I have to right click and it will get to zoom all the components which I have. Everyone can see the components on the screen.
Yes.
Okay. Okay. So for this, I will take one resistor. And I will just now connect the dot from 1 to, I will connect it from positive to negative. Now simple, I have connected one resistor to my power source. Now I have to measure all this, right? So,
Keep talking.
so now here I will take different measuring instruments. Like I have voltmeter and an ammeter. See, now from here I have said the basics. Also we have got to learn here that we know theoretically that we connect the voltmeter in series and ammeter in always in ammeter in series and voltmeter in parallel. So I have to connect them as as per that. So how the so in series I have directly connected my ammeter in between the my phase line, right? But I have to connect the voltmeter parallel. So how across my resistors? So how I will connect this? Just simply connect this to my positive and this one. So it get parallelly connected to my resistor. So and I will switch on the simulation. As soon as my simulation is turned on, I can see the voltage my 24.1 volt. Okay. Now here we have the different measuring instruments, the real looking instruments like multimeter and the clamp meter. So we know the multimeter we use for measuring
Hello.
the voltage, AC voltage, DC voltage and all. We can learn how to use it very
एक
easily.
मिनिट कुठला आहे ते?
Multimeter.
हॅलो.
Hello.
हो कुठला आहे?
So I'll just connect this to my power source and we can measure. So I have connected to AC voltage, it will not show me any voltage. But as soon as I will convert it to DC, as my power source is DC based, battery based, I can see. And if here I have negative, right? So if I invert this, we can take it easily. Now I have to measure the current. So what I will choose in multimeter, so clamp meter also. Now if I have to measure the current by using clamp meter, how I will just I have to select a DC ampere, sorry, ammeters knob and take this clamp and measure on the line. Here I can see 24 24 milli ampere. And if now as of I have shown, I can change these parameters. Like if I have to change my power source from 24 volt rated voltage to 12 volts, and my resistor here I have 1000, I will choose 100 ohm. And also the different minimum, maximum power, maximum resistance, maximum operating voltage, all I can change and monitor from here. So here we can see, as of I have reduced the resistance, my current has been increased. As of I have reduced my resistance, so my current flow has been increased because resistance is opposition to my flowing current. Okay, flowing electrons. So it was like 24 milliampere, now it is 241. Similarly, now I will show you a simple RLC circuit and the use of oscilloscope, as we have an oscilloscope option also. And also it is a 4-channel oscilloscope. So we can use it very easily, and how to use and see and different waveforms and all. So I will start with an AC source and a simple resistor, as RLC means resistive, inductive and capacitive circuit. So I have to take an inductor coil and capacitor. Okay, I have to change this direction. I
Chaitanya,
can
show
easily,
them illustrated library also, so that they
yes,
will come to know what exactly the 3D aspects and catalog also.
yes, sure. I can easily transfer their different angles and all. So just I have to connect these dots and my wiring will be get completed. So there is no harm. The best is thing about this software in electrical term is this is the safe simulation, because there is a very high risk of accident or the electric shock while learning the electrical things. Now, as of this is the small single phase circuit, but also for the 3-phase circuits and all. So we can't easily hand over all the high voltage or the electrical component directly to the students for learning, but this software allows to make the connections as per the students curiosity also, what will happen, or how the circuit will behave if I do the wiring in this way, or the uh, the connections. So this software allows us to do mistakes and learn from them too very easily. So safe simulation, industry ready knowledge we are getting from this. And we also learn how to do the fault finding and all. So I have connected out again and one voltmeter and one, just we will try it. See, now here my current is 0.1 ampere. So I will just, so here with clamp meter we will check the actual current. So it is 0.1 ampere means 1.103 milliampere. Okay, so I can change these things. So digital, we can also see the difference between digital meters and the analog meters too. That we can get the values up to certain decimals too. Now, as we will see the oscilloscope. So see here, I have different channels. So I will use the first 3 channels. So I will connect this my yellow probe to my resistor, then the red one to my inductor, and the blue one to my capacitor. So as I will just do the auto scaling, and I have this circuit waveforms now. As of my power source is AC, we can see the waveforms in sinusoidal waveform. Okay, so here we can see that easily. As we know, we have connected yellow probe at resistance. So see, my yellow waveform is for my resistance, then my blue waveform is for my capacitance, red for my inductance. Now, for example, when my resistance, like my yellow waveform, is at its peak, my induction and inductance and capacitance is at 0. See, and when my inductance is at a peak, my capacitance is at its lowest or the negative lowest past. So we can vary such things. I can vary individual wave also. We can measure different calculations and all by using this 4-channel oscilloscope very easily. So we can do different circuits like Ohm's law, which we have shown, then Kirchhoff's voltage law, then the uh, rectifier circuits in the power electronics. In we can see different rectifier circuits, inverter circuits, and all. So now I'll just easily make in very short time a simple motor starter circuit, and it's also not a motor starter circuit, also it direction control, and we can see how easily students can understand how we do the connections, then what is the basic difference between our power circuit and the control circuit, which is the main thing, that power circuit connection, then the control circuit connection, in which power circuit connection is, we know it's little bit easy, but many times student get confused while doing the control circuit. So we will start with it now. Then I will show different types of illustrated components too, for our motor control circuits, illustrated AC DC and all. Then we will also see illustrated dual starters, star delta and different starters too, with illustrated diagrams. So for making the 3-phase direction control circuit, I will needed a power source. So in my NIBA library, I will go to my power and energy sources, in which there have been the classification of as per their classes and all. So I have battery, single phase, now 3-phase. Okay, so in 3-phase also I have the 2 types of connections which we needed as per our application. Like I have 3-phase source, 3-phase neutral, so many components, which the main advantage is like many costing is being reduced. So I have such a vast number of components, I can have there is no need to buy such hardware, because I can easily learn all of them in this single software only. Now see, I have a single 3-phase power source L1, L2 and L3, which means our R, Y and B phase. Okay. So now I have to start a motor. So I have different motors. Now the motors library is also very vast and very easy to learn. So we will start with the DC motors. I have different types of DC motors: DC series motor, wound mechanical connections, then different types of DC separately excited motor, DC shunt motor, DC compound motors, permanent magnet motors. So this software is not only giving us a standard component, but all its required types as per the actual technical knowledge, or the actual technical circuits which we have to win, like where I have to use wound motors in AC. Now see, I have single phase AC motors also, asynchronous motor, series single phase motor. Now we come to the 3-phase asynchronous motor. Okay, so in motors I have different like asynchronous motor, squirrel cage, wound, which all the electrical domain faculties would knowing everything which I am showing. So induction motor, asynchronous motor. So as of many of the students or the people are only know the AC and DC, but there are the different types and connections which I have. Now I have also this for what is the star connection, what is the delta connection, and then how does the power supply gets converted, how the timer relay works in the circuits, everything we can easily connect, see the actual hard wiring also and the controlling also. So I have taken this asynchronous motor 3-phase AC. Okay, I will place my motor over here. I have this will show my different output torque, variable load torque, and angular speed. If I have to just see my angular speed, I can remove other things, and my in my edit tab I can also increase this. Now for to turn on, if I give the directly connection to my motor, it will get started, but I have to control it. Okay, I have to stop and start it as per my condition, and also control its direction, whether it will move in forward direction or reverse direction. So I will show you the same. For that, first thing I will needed a protection to my circuit. So I have in my protection library, I have different protection devices in which I will take one 3-pole protection circuit breaker. So this is my circuit breaker. So can everyone see the components clearly? Okay. So one protection device. Now I have to on and off my circuit. So for that I will need and one contactor. So I have contactor poles. I will take two contactors. Okay. One for my forward direction and one for my reverse direction. These are my contactors, and also one thermal overload relay for my motor protection. If my motor will go above rated current, or there is a if my motor get heated, it will cut off the supply. So I have to make the connection. I will just easily, I have different now options over here. If I have the polyphase configuration, I can in one time I can connect all of them. See, and I have to now switch the direction. So for controlling the or switching the direction of a motor, what I need, I have to switch the two phase, any two phases of motor, right? From L1, L2, and L3, I have to switch. So for the same, the input to my both the contactors will be the same, but output will get changed. So I'll just change this one. That's much easy as it is. And I will, the middle one, I will keep the same. So my power circuit is being now ready. Okay. So what in my power circuit, what I have, a 3-phase power supply, a protection device, a circuit breaker, my two contactors for controlling the direction by switching the supply, and one another protection device which is my overload relay to protect my motor from overheating and overcurrent. So I have to control now this circuit, that I have to control the electrical flow and the direction of a motor. So I have to make one control circuit. But it as of now in 3-phase here, as of I have used NEMA standard. So that's why the basic standard voltage is 20 volt. But in India we use 3-phase voltage like 415 volt. Okay, 415 volt hai. I will just change this to 415 volt. Now I have to you make an control circuit, but my control circuit is working on a single phase, and this is my 3-phase supply, having each phase a full full phase. So for that I have to step down my voltage from 415 to 120 volt or the 230 volt, right? So for that I will need one step down transformer to reduce my voltage. So in my transformer library, which is also a very last library, we can say, because I have transformer 2 winding, 3 winding, or center tapping, coupling, all these components, different types of transformer. I will take one step down transformer and easily connect it with. just I will connect my two phases to my transformer, and in my double click, when I will double click on my transformer, I have this parameter settings in which I will choose my primary voltage 415 volt, and I have to step down it to 120 volt. Okay, my control circuit is of 120 volt. If as per my uh, application, if my single phase circuit is of 230 volt, we can set as per that. And also, if I tick on this, it will show me on my screen. So I have to start and stop my motor. So I will need different switches. Now from power library, we will move to control library. In this, I have different protection relays and all, right? So I will also take one single pole circuit breaker for my control circuit protection. I can connect it here. Then I will need different switches. So I will take one push button, start push button. I will name this for, if now I have to also on and control the direction. So I will name this forward. This is my forward switch. And one more, and I will connect it over here, and I will rename it to reverse. As of my, these are my forward so start switches. I will need and one stop switch. So I will take one NC contact now. So all the concept like what is NO contacts, NC contacts, we can easily clear over here. I will rename it to stop. This is my stop switch. See, easily I have connected all the parts. Now here, these are the dark lines for my power circuit or high voltage circuit. I have to change this to my control wire. So I will just click on this. It will get changed. Here also, I can change different. Like I have to change my wire form, DC control plus minus, then RYB or AC control neutral. I can select my wire type too. So here or everywhere I have to use my control wire, and also in my home tab I can choose that. Now I have to switch on these contactors. So for forward direction, my flow will be from this contactor, and for reverse direction, I will switch on my this contactor. So to switch on and off these contactors, I have to use different relays. So I have different relay contacts or the relay connections, relay coils, contactor coils too. So I will use the coils, and I will name it to C1, my contactor 1, and contactor 2. So, and I will just easily connect this. Now, here I have given my these two coils C1 and C2, and I have, when my this coil will get energized, my this contactor should get on. So I have to make the connection in between them. So I will just double click on this contactor and search the name of my coil C1. So see, I will just rename this to C11, and this is my C12. We can also name according to our one line diagram like K1 and K2 too. So what I have used over here, the naming is as per our. So So I have connected this contactor to, I link my this contact to C11. So now we can see the blue lines, blue contacts on both my relay coil also and my contactor also. So whenever this coil will get energized, my contactor will get closed and allow the supply. The same thing I will do for my second one. I will connect it to my C12 and it get connected. But now this is just to switch on and my stop connection will be off. But I have used these push buttons, right? So push, I have to do the holding circuits and all. So I will need a different contacts, NONC contacts. So I have different relay contacts too over here. So I will just easily connect this. So easily students will get the what is the holding or the latching concept. And one more important thing I will show, that is the interlocking also. So how easily we can show the interlocking, that now it will get holded, right? But when when my circuit is in forward direction, my reverse direction button should not work or the coil should not get energized. So I have to give the interlock. So I have to connect NC contact in between them. So I will just switch this to C12. So now whenever my this coil is energized and in reverse direction, and if I directly I switch on the power forward button, it will not get on. Same thing I will do for the forward too. And just I will connect this my negative to. Yeah. Okay. So our circuit is ready now. See, in my simulation mode, I can see the power only supply to up to this point, that these blue lines. But there is all the other lines are gray, unless I will close my circuit breaker. Just when my circuit breaker is closed, my supply has gone up to my for start buttons, not uh, again it. So here also my supply is up to my contactors only, not above them. Now I will start my forward connection. I will put my forward switch on. As soon as I will switch on my forward switch, my motor starts rotating in forward direction or the clockwise direction, and my angular speed of my motor is 1800 rpm. Now we can also, in running condition, we can change the torque, or we can change the load or increase the load on motor and see how the speed will get reduced. So as my zero load or the no load condition, my motor is at its full rpm. But as soon as I will increase my load, my motor speed or the rpm, rotation per minute, is getting reduced. Okay. Now I have to rotate my motor in opposite direction. See, so I will press my stop button and motors will get reduced. Now I will put on my reverse button. As soon as I will, I am getting press my reverse button, motor start rotating in opposite direction. And also we can see my angular speed is in negative now, minus 1767. And as soon as I will get connected, see, I'm increasing my load, the motor speed is getting reduced or rpm is getting reduced, and above certain level my motor gets stopped. Why? Because I have connected my protection device. So now one more thing, here we can easily see the voltage. Now we can measure different voltages, which is my what is my phase voltage, what is my line voltage. So what is my line voltage now? 414 volts, right? And what is my See, the difference between my two line voltage is same. Now I have to check my current, right? The current flowing from my each phase. It is up to 7.93. But I will now stop the motor. My current is 0. When again I will start my motor in forward direction, see, my current started, start was increased and then it gets constant at 7.93 or the 8 ampere we can say. But why it is? Because there is a high inrush current in this motor, and those also we can see in our plotters and all. Now, this was my generic standard diagram or the standard circuit, which we also see in our syllabus and all. But what about the real connections? As we say, the software gives the feel of connecting or the working on the real circuit too, right? As real hardware. So if I have to teach students the actual wiring of my house wiring or the contactor wiring, okay, but that's why I don't have to purchase the 20 different kits or the 20 different hardware. I can teach all the batch of 20 students in this software and then hands-on practice on one single hardware kit. Okay, so there is no need you to purchase 20 hardware kits. Besides, you can take 20 users this software license and one hardware kit. So how it I will show you now. So I have here one open library, that is my illustrated library circuit. So this all the library I have shown till yet, this was my generic library. Now I will show you the different illustrated library. This is my DC electrical illustrated. Then I will just open all the first my motor control. Then I have in electrical I have residential electricity circuit library. We'll start with first motor and renewable energy circuit. Here I have different energy sources. Like we have seen different energy sources in generic. There was just, but here I have this my complete pole. The illustrated one, AC sources and all. Then in three phase also we can say I can take directly a transformer source too. Three phase transformer source, three phase pole for creating a real like circuit. Okay, then I have different energy converters, different devices. As of I have shown you different circuit breaker. Okay, so I have the same in my illustrated also. I have if see, I will just switch on, switch off. Then I have different protection devices, VFDs. So I have also the different VFDs too. We can connect different VFD circuits, different motors. These are my DC motors. These are my AC motors. See, 6 connectors, 3 connectors means for my star delta connection, my single connection. I can replace this motor with my illustrated motor also. And one more thing is the contactor connections. So see, this is my contactor. I can easily see this is my actual now. The actual we can say the Schneider or the any other LNT contactor we see the sir. All the connections and all the markings are also same. So I have to do the actual wiring which I have to do in my panel. I can learn how it is been done in this. Like these are my L1, L2, L3 input and output connections. This is my A1 and A2 contactor energizing coils. These are my NONC contactor contacts for NONC contacts for making different connections, holding and interlocking. So now I will show how we can connect this circuit. Okay. See, now this is my pre-made circuit here. you can control and carry out wiring of control cabinets and equipment. So first thing, this is my RDOL circuit, reverse direct online circuit, right? Which we have seen right now. This is complete one. But I have to also, I can create this real looking control. See, I have a power source, a different, also I can connect the contact, the circuit breakers and all in this. Then I have my two contactors, for one is for my forward, one is for my reverse. And this is my overload relay. These are my start stop buttons. See how the connection is being really I have made. With there in previous circuit, I have to make the links between my coil and my contactor, right? The virtual link. But here I have to do the actual wiring. So how my parallel I have they given this my holding in between my start and stop. They how can I reset my overload relay or stop from my overload relay kind of point. I will just simulate this one circuit. See, now my simulation is done. The all the connection, the blue lines you can see, the connection has gone up to my start stop switches and all. So I will just start it. And we can easily start our motor. The same thing we can do over here. So this was the basic. Now, as we have the time constant, I will show the pre-made circuits which we have in our, which the capability of the software. That how easy is the electrical concept, how easy to learn the electrical concept by using this software and the power of the software. Okay, so I will just close this file. As in the introduction, sir introduce you. Now the electrical, I have learned my electrical part, okay, but I have to implement it somewhere, right? So in an actual industrial control, if there is one pneumatic system, so pneumatic system works on air pressure, but I have to control it, and also the compressor and all, and the compressor is of my dual starter. So how I can connect this electrical with pneumatics and control it with a remote controller or a PLC or a proper automation. So there is one circuit in which I have shown. See, so this is my circuit. Here I have connected one power source to my contactor, overload relay, and one my motor. And here I can see one shaft. Okay, so this is my compact logics Allen Bradley PLC or one PLC, from where I have connected a start and stop switches, different sensors, and output coils for to start stop control my electrical control. Okay, then here this is my illustrated pneumatic circuit in which I have one motor, a compressor tank, my FRL unit, and my forward reverse pneumatic cylinder. Now here I have connected that motor shaft. So I will just now show all these different slides in single one. See. This is my PLC and electrical circuit. This is my pneumatic circuit. And this is my PLC ladder diagram. This is my PLC ladder diagram. See. So now from basic electrical circuit to advanced and now industrial control circuits, we can see I have one electrical circuit, power circuit, PLC control circuit, and my actuators, or I can say this is my pneumatic system and my PLC ladder to program the PLC. So I will start with my start as as per that my ladder also will get energized. And here I can stop. And I will just switch on this. See, and here I have made an one sequence circuit where my cylinder is getting or is there is an one clamping circuit for forward and reverse as per my timer. It is get forward and then reverse, then again forward. And it is all everything is done in this PLC ladder. And then all the my actual hard wiring of PLC, like what is the my power. So the main thing is the wiring part, like what is my control wiring, what is my power wiring, how the powers that my sourcing part, my syncing part, how PLC's power system is getting work. My PLC is working on 24-volt DC source, so I have to need one AC to DC converter, so which is converting 120 volts AC to 24-volt DC. Then it is getting energized. Then I'm taking input and outputs, then different coils, then relays. So how they are being connected. So this is my actual representation where I can see where I can learn the raw electrical concept. Then the actual bigger we can say three-phase circuits, three-phase star delta connection, dual connections, VFD control circuits. Okay, these are the illustrated libraries. Now now here I will show you the different my electrical circuits, right? So now I will show you my residential electrical library. So this is my in this I have residential electrical means, like now for electrician trade we can say there is one more part is house wiring or the residential wiring part, right? I have two-way switches, three-way switches, and in both these are my MCB type switches. These are my now what is the difference between how many ports are there in between now? See, this is my two-way switch, this is my four-way switch, the simple on-off switch, and this is my four-way switch. So how many ports it is having, how I have to do the wiring and all. So I can do easily. So I will just connect one thing. So I will take one two-way switch, one light. So I have different voltage based or the different power based components, like 124 volt. I will take 60-watt bulb and one outlet, different outlets, power outlets I have. All the components which are required, table fans, testers, short creator, outlet testers for my residential electrical circuit. Like this is my connectors, junction boxes, or the power outlets we say. Then the electrical panels, I have different circuit breaker, right, from 15 ampere single circuit breaker, 20 ampere, 30 ampere, as per my load I can choose this. My complete electrical panel also I have. Then I have the doorbell, how to do the doorbell connection, different power sources and all. I will take one power source. See, now I will just connect this one to my button input. Okay, and then the output of my switch will go to my bulb, and this bulb return the neutral path will go to my neutral connection. And the earthing, which is very important in our domain, that how the earthing should be done, what should be its strength, which and all we can see. So I have connected this. I will switch on the simulation, and I will just click on my button and on and off. Basic, ekdam simple, just connecting dots and lines. I can easily connect them. And I have to, if I have to measure the power difference between them, the voltage flow, I can easily check. And one more part was dynamic measuring tool. So here I have one dynamic measuring tool in which I can check the voltage or the power between them. If we can easily connect now. So this is our residential electrical library. Now I will show you the different PLC library. Okay. So in PLC, illustrated PLC library, I have Allen Bradley, Bosch, Eaton, Koyo, LS Electrics, Mitsubishi, Schneider, Omron, and Siemens PLC. See, as we see this, this is my Allen Bradley PLC. Then I have Eaton PLC. And he in my sub library, you can see there I have two options for standard diagram and for electric technical diagram. Means if I have to make a complete MCC panel control by using remote control or the PLC control PCC panel, I can use. If I have to use the integrated, means hydraulics pneumatic systems with my electrical or the complete PLC automated control circuits, I can use this. I have Siemens also S7 1200 PLC, logo PLC, and just not the PLC, the actual overview we can see. Now this is my Siemens S7 1200 PLC, which are hardware which we saw on previous in the starting. I have the input connections, actual 24-volt DC inputs, number of inputs, number of outputs, 14 inputs, 10 outputs. The actual my same PLC is having, and we can run it and check. Okay. Now we are going to see the renewable energy diagrams now. So renewable energy, we have the two parts, the solar technology also and windmill circuits also. So first we will see a solar connection to our household load. And not only a solar, in this we have all the components required for my solar circuit, like my different types of solar panels. I can create the different load or the array as per my load. Then I have MPPT connectors, batteries, and all. See, here I can also show in my simulation tab. I have option here, plotters. So graphical representation of my outputs at power output, current, voltage also I can show by using this graph. See, so this is my solar tech circuit where I have this irradiance or the sun, which we can say this is my power. This is my these are my solar where I have connected all of them in series and then connected it to my MPPT algorithm. Before that, I have connected one ammeter, voltmeter, and wattmeter to check the energy, how much energy has been generated by my solar panels. Then here, by after my algorithm MPPT panel, I have MPPT charger also we say, which firstly charge this battery, then allow my supply to my house load. I will just show directly. I will show you the simulation. Here you can see as my irradiance or the irradiance value is my high. If I will reduce this, see my I can we can see easily the current, voltage, and the power. If I will increase this, my irradiance value, my generation also get increased. Now, as per that, we can say after 110 volt, this is my 120-volt battery. I can switch to AC my load. Now this my here I have to switch from DC to AC. I will need an one inverter. So this is my inverter block where my DC input has been converted to my AC output. So I will generate this and switch on. And here also I have used 3x2 way circuit. So from the same switch, I can easily convert. Now as the load is too much, my battery get degraded, so now it will get switched. Let's see. And also in renewable energy, I have like energy sources, photovoltaic batteries, different types of photovoltaic panels, wind turbines, and all. So we cannot only not only
Chaitanya,
basic electrical circuit. Yes,
hello Chaitanya.
yes, sir.
Why don't you explain them that where it is useful for them? I have told you thousands of times that you please explain the benefits of what you are telling this so that they can correlate in their day-to-day life that how it is going to make their life easy. So
So the
for
main
God's
thing
sake,
is
could
the
you please
wiring.
keep on telling this?
Yes. So the best advantage is the actual wiring, that the concept, the what is the flow. I'm getting very easily because many times it is like in theoretical part we don't get easily, but here how the wiring is going on and all we can see very easily. Now we uh, we will go to residential circuit. So as I have shown you the residential component diagram. We have created one 4-room actual working residential circuit. So in this circuit, we can easily trace all the wires, how from which my input is going to my मेरा कौन सा वायर कौन से पोर्ट को जा रहा है, मेरा न्यूट्रल कहाँ से आ रहा है, the actual the complexity of this circuit that we didn't get understand, the wiring part, the connection part, power part. This is very easily in day to day life also we are getting confused. See, now this is my 4-room. This is my power source. This is my meter. These are my MCPs which we see daily in our house. These are my different MCPs for different rooms. Room 1, 2, 3. Okay. So firstly, I will switch on my TV, fan, different lights. Same way for my this small room. Then here also. So how these connections are getting connected. Here I have the AC fans also.
Chaitanya, can you show that if power, rating goes on that MCB can trip?
We can easily here we can see.
Yeah.
See,
You zoom that and then show that consequence.
these are my 15 ampere MCB. If it is get switched, See, I will first switch on all them, then I can show easily. See. Now everything is on.
Yeah.
As soon as my this MCB is getting off, see,
Hello,
everything is
Ranjit.
getting off.
Hello.
Yes, sir.
What about the earthing connections? I could not find earthing connection in industry wiring or
Yes.
in domestic wiring.
So see, here we have the earthing connections. Like from my fan, I have made it to in one. Okay, and to my power source. The earthing connection from my components to my switchboard. Then it is getting to my connections. So different connections, like see here in my residential library, I have different outlets and all. Here there is one connection for my earthing. So for each outlet, okay. Then in outlet also I have the different ELCBs type of outlets too, and switches also. See, here we have earthing. And for previous, which it got skipped, we have also the different ground connections to give to our different circuits and all. It will just getting open. Here, see, I have connected one ground connection to my transformer at this point. Here also to my motor. This is my ground connection which I have to do, and demonstrated it by different points and all. And it is also like, if I will delete this connection one again. If I have connected this with my normal line, now by changing it to my earth, we can easily demonstrate it to my earthing point, that this is my earthing part and all, and easily relocate it also.
Okay, and one very good news I would like to tell all viewers and participants that recently we got connected with Schneider Electric. It is the world's very renowned company in energy transmission, and we are happy to be tied up with them. And all educational equipments, Schneider has taken the decision to globally manufacture it and then give it to the electrical engineering or core automation centers. So people who are interested to know about Schneider's and then how we can build that digital twin in automation studio, it will be very complementing thing that in simulation lab you can learn wiring and then testing and validation and simulation, and then actually do test that wiring on hardware or or Schneider kit. So we have electrical installation and industrial installation trainer kit of Schneider's, and we already have created digital twin for that as well. So Chaitanya, can we show that?
Digital twin, like in that kit we have
No, I mean
uh,
one section you already have built, right?
uh, So in that kit, it has been shown that by using PLC, we are controlling the motor also and other thing also, right? So in dual starter connections and all.
So, do you have that photo of that Schneider Electric trainer so that they will be able to correlate that how a physical trainer kit can be demonstrated using or can be tested on computers, because you can't
This
expect
was
20 kits to be purchased by students. So it will be very costly material for them. So whatever you are showing them now, we can build the electrical schematic on software and then check the wiring whether they have done properly or not, and then take virtual instruments and then check whether that voltage, that current is coming in no, or not, and then accordingly you carry out your experiment. So uh, if ITI instructors are there, I will make it more simple for them. आम्ही स्नायडर इलेक्ट्रिक जी फ्रान्सची सगळ्यात मोठी जगातली कंपनी आहे, ज्याचा जवळजवळ लाखो कोटीचा टर्नओव्हर आहे, अशा कंपनीचे ट्रेनर्स किट आपण आता इलेक्ट्रिकलच्या मुलांना देणार आहोत त्यांच्या लॅबसाठी. परंतु आपली बॅच साईज खूप मोठी असते, 20-20 मुलं असतात, कधी कधी 25 मुलं असतात, तर 25 मुलांना 25 किट आपण देऊ शकत नाही. We can't afford to give each kit for each students to practice. So what we can do, we can first of all take them on simulator. So for example, we don't give entire aeroplane in the hand of pilot, trainee pilot. So first what we do, we train them on simulator and then actually take on actual hardware. So theory or theme is that in automation studio you would be given all these virtual instruments. हे सगळे रांगोळी काढल्यासारखे तुम्ही तुमच्या सर्किट डायग्राम काढू शकता आणि ती फॅकल्टीने चेक केल्यानंतर मुलांना कळतं की वायरिंग कसं करायचं, स्विचेस कुठं लावायचे, मोटरला ऑन ऑफ कसं करायचं, तो VFD जर ड्राईव्ह असेल तर त्याचं कनेक्शन कसं करायचं. तर हे सगळं कॉम्प्युटरवरती केल्यामुळे सगळ्या चुका माप असतात. तिथं मुलं जरी चुकले तरी काही त्यांना शॉक बसत नाही किंवा काही डॅमेज होत नाही किंवा इक्विपमेंट उडत नाही. सो सगळं टेस्टिंग त्यांनी त्या सिम्युलेटर वरती केल्यानंतर मग ते ऍक्च्युअल फील्ड जाऊन ह्या हार्डवेअर वरती घेऊ शकतात. सो चैतन्य, प्लीज एक्सप्लेन धिस किट टू देम.
okay, sir. So this is our industrial control and drive kit, in which we can see the 3 different columns. So in the first left column, there is a switchgear system, then different contactors, dual and RDUL contactor connections, and the main part is in this complete we can see the all the wirings, how it is going to my panel, actual panel, wire routings, then कौन से वायर में कौन सा कॉन्टैक्ट जाएगा, फिर उसको कंट्रोल करने के लिए मेरे को मुझे उन NONC में कैसे कनेक्ट करना होगा. Then in third we can see the different wire connectors, then push buttons, start, and the selector switch. Now the main advantage in this that according to my diagram I can connect all the wiring very easily in this complete hardware setup. But the this part first we can teach on the simulation, because this will reduce the 60 to 70% the accident part or the safety issue from my from the students and the as well as trainers perspective also. Because directly by teaching theory I cannot give free hand to the students to this kit. Okay, this is the complete 3-phase supply we can say, or the single phase supply. There is very different. If only I have to change the direction, I have to change the 2 wires, right, 2 phases, but it is very risky for students. So but I can teach this same thing in my simulation which I have shown. If the connection is wrong,
चैतन्य, हे काय काय ते जरा एक्सप्लेन कर ना, ह्याच्यातलं हे नक्की याच्यातनं काय शिकू शकतात मुलं.
हा, आता यामध्ये काय आहे की माझ्याकडे मोटरचे स्टार्टर सर्किट आहेत, ते शिकू शकतो. मोटर आपल्याकडे इथे खाली एक मोटर आहे, 3 फेज मोटर आहे, त्याचं मला स्टार आणि डेल्टा कनेक्शन असतात. ते वायरिंग कशी असते ते शिकू शकतो. त्याच्यात फॉल्ट जर झाला तर तो कसा ओळखायचा ते शिकू शकतो. त्यानंतर इथे मिडल पार्ट मध्ये वी हॅव अ VFD. ठीक आहे. सो द सेम थिंग मला VFD ने मोटरची स्पीड कंट्रोल करायची. टू कंट्रोल द स्पीड ऑफ माय AC मोटर बाय युजिंग PLC. मग त्याच्यामध्ये डिफरंट पार्ट्स येतात जे
आता हे मेश मध्ये का दिलंय, याचा काय उपयोग आहे? आणि इंडस्ट्रीमध्ये असताना हे याची प्रोसेस काय असते म्हणजे हे जरा सांग मुलांना.
आता हे जे मेश आहे ह्यामध्ये कम्प्लीट वायरिंग जी आहे ती पूर्ण क्लोज्ड असते फर्स्ट इन इंडस्ट्रियल पॅनल्स अँड ऑल. जर तुम्हाला डिरेक्टली मी एखादा पॅनल जर दाखवला तर एव्हरीथिंग इज क्लोज्ड एनक्लोज्ड अँड ऑल. यू विल जस्ट सी द टॉप मोस्ट कॉम्पोनंट्स लाईक माय ऑन ऑफ स्विच गिअर अँड ऑल. बट द ऍक्च्युअल बॅक एंड पार्ट की नेमकं कोणती वायर
Zoom
कुठून
कर.
गेली आहे, त्या फेऱ्यूलवर काय नंबर आहे, ती कशामुळे तिथनं गेली आहे, त्याचं अर्थिंग कसं केलंय, प्लेट अर्थिंग आहे, पोल अर्थिंग आहे, हा सगळा पार्ट जो आहे तो मला यामध्ये पाहायला भेटतो. मग मला त्याला टाइम लावायचा आहे का काय, जे काय माझं ऍप्लिकेशन असेल, मला त्याचं वायरिंग शिकायचं. एका कॉन्टॅक्टरला मला 3 वायर कनेक्ट करायच्या, 3 वायर करायच्या, बट त्याला मला ऑन ऑफ करण्यासाठी अजून एक्स्ट्रा 3 वायर लागतात. ते नेमकं कुठे जातात?
So you
मला
mean
फक्त
to say that in your electrical whatever panel we go in the industry, we
येस
really don't understand what exactly the wiring structures are. So in such a trainers, if they are
येस
kept open, it will be very easy for students to know the source and the end point
येस
of the wire.
येस द
And all
लोड सोर्स
equipments
अँड
they can
कंट्रोलर.
plug and play. And with in a modular aspect they can really think that how industrial electrical technologies are installed in the industry, isn't it?
येस सर.
Okay, now similar thing, whatever the wiring you have, I mean in this students can take individual components and plug on that, put on that mesh and then do wiring. So it is really great for students to gain that confidence. But हे सगळं करायच्या अगोदर आपण हे सेम सॉफ्टवेअर मध्ये घेऊन त्याला सिम्युलेट करून टेस्ट करू शकतो का?
हो सर. आता
So
मी जसं
can
ते
you show that part on Automation Studio that की हे components सगळे तू घेतलेत, you have taken all these components and then because we can't afford to buy 20 kits for students. So on computers, on the same computer lab, students will be able to perform that simulation circuit and they can go and actually perform their practicals on kit later on once the faculty approves him.
येस.
Yeah.
Okay, I will just share my screen. I will show the components, required components, how I can easily drag and drop.
Oh, last time you had shared both the screen. Similarly, now you keep this trainer kit aside and then simulation circuit aside. Swapnil has sent you on WhatsApp that photo.
Yes, yes. Just a second. I will just
So that faculty will come to know that how industrial technologies are exactly mimicked in the software and they are working similar way.
yes, sir. Just
So we can save their lot of cost, lot of space, and accidental issues also. Because designing control panel is the big issue, and even B final years engineering students also don't know how to connect electronics devices with electrical system.
okay. So I have shared my screen.
Yes.
Is it visible?
Not yet. Yes, now it is okay.
Okay. So this is our installation control and kit, right? Now
Yes, yes,
in
yes.
this C, here I have switch gear system, means
Yes.
power, my protection device, and my power source.
You can zoom that.
So here you can see
Fantastic. Yes. Yes.
this is my power source, switch
Yes.
gear, and then my motor control circuit and the contactors.
Yeah.
And here downside I have this motor.
Right.
In this you can see the 6 different connections, right? 1, 2,
Right.
3, and
Right.
here also we have 6. So why these are the 6? In a motor there are 3 windings having both the ends connection. So this is like we can start this motor on star and delta connection. Now I have to make this similar on this simulation. First I will show you the components, then we will see a complete circuit.
Right. Right.
So this is my motor control circuit illustrated part. In this, see this I have the 3-phase power. I will take this one. This is my power. You can compare it with, see
Yes.
here I have the input power. We can say from here, I have given the input to this circuit.
Okay,
So same it
fine,
is my
fine, fine.
power.
Yes, yes.
Now I have protection. Here we can see this is my contactor or the switchgear system for my protection purpose. So here also I can take these fuses or the coils.
And can we take of the make of Schneider also? Is that library available of Schneider's?
So can I show that online different manufacturers catalog in the last or
Okay,
currently?
okay, fine, 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 fine.
Okay, yes. Oh, okay, it got open.
So you have all manufacturers catalog, and we can select them also to make it more relevant to that company specific equipment that project owner is going to use it, right?
Yes, yes, yes. See here, I have Automation Studios, its own components, then AgroHitos or the CKD, Eton, then different like Mitsubishi
Mitsubishi,
Electric,
Honeywell.
SMC, Vivo. Is this okay? Oh, you can see the names. Tech. So I will just see. Mm, Here I will apply the filter. Filter technique. So I have manufacturer control. Okay. Here I have different control components like timers, sensors, PLCs, protections, and all. Same way for different basic other things. Same if I have to use the Eton components. See, here I have solid state motor control and protection.
Okay, okay,
So I have different NEMA contactors and starters and all. So if I have to make this by using particular manufacturers only, I can. Now
okay, okay, great.
here I will show. See, I have taken this. I will just remove this fuse. I have my power source. Okay. Now I have contactor.
This is the
Now
right
see.
way to understand.
Raul users solution, right? Cost of the software. Dr. Raul user.
See, this is the contactor. You can see. This is the similar one from here.
मी उत्तर देऊ शकतो
हो, देऊ शकतो.
कुठे
Dr.
Here
Raul
we
user.
we have the all the wirings and all. So same way we can connect here. Then the different contactors and all, contacts and all. Sorry, NONC and all. We can control as similar to shown in previous circuit. Then if I have to use double contactors similar to this, if I have to use the timers and all, where it is overload. See here there is an one overload relay. So I can also take this one. I can connect it over any of them. Okay. There are different connectors and all. We can use this or without them also we can replicate. Now here we can see this here. There is a box on which there are different on off buttons, right? Push button, emergency stop, selector. Similarly, we have for stop and I can use this lamps, relays, timers. Is similar to timer relay. Okay. Then potentiometers also, push buttons. So see, we have all the components which we required for this. Then if I have to control it by using VFD also, then I have the VFD also in my library virtually. I can use this VFD. Then the main thing is here we have only one motor, but in simulation we can use different with our load also. Three phase with variable load, we can vary the motor load also by using this spring load. Then motor delta, induction. See this 6 connector motor also. Sorry, 6. This all the components, right? We have the motor and all. And the third part here we have in this image in our kit. This is the same by using the starter only, but by using the PLC. So previously I have in previous circuit I have shown you that how by using PLC we can control the electrical circuit. Now I will show you how the similar circuit is there. See this one. Now this circuit we have.
आणि चैतन्य हे सगळे कंपोनेंट आहेत ना ऑटोमेशन स्टुडिओ मध्ये?
Yes, yes, yes. All the components.
And
Even more variety of
virtually
that
we can
say.
virtual instruments and measuring instruments also we can use to take the help of what current and what voltage it has, isn't it?
Yes, 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 yes. Just I will show you one file, then it will get clear. So actually the hardware which the Snyder is having, no, sorry, not this one. This one. So which having in our hardware, we in software we have the different varieties of that also, just not only that particular part. So that is the more advantage we have. And now I will show you one illustrated complete star delta starter circuit. So this is my star delta. So is it similar to like this rack or this mesh that I have this all the contactors and all in one part, then and the switch gears and all here, the fuse holder, all the indicators part, and the on off part is here, and their wiring and all stop whether it is fault or start and stop. And one more part, so the similar all the components we can share.
So it is exactly the same components you have laid down on virtual environment.
Yes, yes, yes. The same thing which I have required. The virtually also the connection and the port. It is not like a standard part only that this is the standard diagram. And actual when we are going to actual work or in the industry, there is like ये तो अलग ही level पे काम चल रहा है. So it reduces that gap between the actual industry level and the education, between the education and the industry. Okay, sir.
Yes.
Okay.
You any questions from the faculty? How did you find this concept of initially building this digital twin in software and then actually think of wiring structure and then go on actual hardware? Any questions, please? Have you understood this? Yeah, some of the participants can unmute and then have a dialogue with us so that we will come to know whether it is being delivered it properly or not.
And one more
Hello.
thing, sir.
Yes.
Yes, sir. Myself, Mrs. Akolkar. I am a faculty in engineering college. I am teaching this subject PLC SCADA
Which college, madam?
from Nasik, Lokneti Gopinathji Munde College, Nasik.
Okay, madam, please.
Yes. So, can I have a training on this? Whatever you discussed, that was very nice. But can I have training, or some of our faculty have training regarding the software before purchasing? What should we do?
Yes, madam. You can be given training also. We can give a separate demonstration also. We can give
Okay.
both hardware and software also. Our theme is to give the detailed, what exactly are required to build for today's
Okay.
automation. For today's automation engineer, what he should learn in electrical domain. So people are informed that they need to know PLC, they need to know relays and all. But how
Yes.
do they really practice it? Because electrical is such a concept that unless you practice it, you can't really
Yes.
understand how exactly it is. And then for fresher, companies may not be able to give their proper attention. But if you can
Yes.
portray to your companies that yes, our student has already gone through such a kind of a training, during the
Yes.
interview
Yes.
also they can be really
Yes. Yes.
can get the good package, and students can be motivated to go for such a kind of a jobs instead of only rushing towards IT
Learning
and
the curriculum. Yes.
computer.
Yes. Syllabus. Yes, sir. That's
Because
why I
this
wanted to.
has, madam, this has really great career, and we have seen
Yes. Yes.
people are very rare to get in this domain, because you will find Java programmer, you can find C programmer, you can find in lakhs of number you can find this,
Yes.
but you will hardly find any electrical engineer who knows all these terminologies, because they are hardly exposed to such a kind of softwares or hardwares.
Yes, sir. Sure. Sure. And one another thing is, if we purchase software, so there is a combined hardware plus software.
Yes, madam, we can give that, because Schneider we have hardware and software
Yes,
we have with us.
that was very nice thing to hear that you have the MOU with Schneider. That is very nice thing actually.
Yes, yes, yes. Because we only work with class one people. There are so many kits are in the market, but they are very untrusty. We can't afford to,
Yes.
But the people who are
Yes, sir.
getting certified from Schneider, it is very
Yes, sir.
likely to get the job in the market.
Yes.
So
Sure. Sure.
we give certification for Schneider also and from SimuSoft also, madam.
Okay, so regarding further information, quotation, all that,
Yes.
to whom should I contact, sir?
Yes, 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 madam. We have that contact number, and our engineer will call you back.
Yes, okay, sir.
Yes, Badal Kumar ji, please.
Yes, sir. Good afternoon, sir. I am
Yes.
from Sweri College of Engineering, Pandharpur.
Swery, yes, I know that. Yes, tell me.
Sir, my question is that, sir, कि जैसे सर ने PLC SCADA पर इंडस्ट्रियल में बताया, लेकिन मेरा कहना है सर कि क्या मैं इसका यूज जो है, जैसे हम लोग मैटलैब सिमुलेशन पे जो करते हैं, वो उससे ये डिफरेंट कैसे है और किस किस पैरामीटर्स पे, जैसे इसमें विजुअलाइजेशन है, मैटलैब में भी है, तो ये मैटलैब से डिफरेंट क्या है इसमें
I'll tell you.
जानना.
See, MATLAB is like an ocean. You need to get very specific on that. It's a programming tools, plus you have certain block set also. Yeah, in this it is more customized more GUI based, and you don't need to program. You don't need to develop any circuit in this. For example, if you want to have AC motor, in AC motor you have number of motors. You have, I mean, you need to know the switch. You have that switch of that particular company. Whether you want to have Schneider switch, Eaton switch, or Mitsubishi switch, that is readily available. You won't find VFD of Schneider's in MATLAB.
So in this, sir, PMSM motor is available. PMSM motor, permanent magnet synchronous motor, in your block. इसमें
You won't find Mitsubishi PLC, Siemens S7 1200 PLC in MATLAB. So it is more customized towards making your control panel in electrical aspects, wiring aspects. MATLAB is more towards R&D and programming aspects.
Okay, this is for application based work.
Yes. See, हम MATLAB use करके कर सकते हैं क्या? Answer is yes, but that will take 1 month. In 1 hour, you can ask your students to do the Kirchhoff's law, wiring करो, काम करो. So more customized होता है ये.
Okay.
So your life becomes very easy. For example, why to reinvent the wheel? आपको wheel क्यों बनाना है? आपको स्नाइडर का VFD चाहिए, आप ले लो. आपको PLC चाहिए मित्सुबिशी का, आप ले लो. उसको वायरिंग करो, लैडर बनाओ, उसको हाइड्रोलिक सर्किट्स के साथ जोड़ो, रोबोट्स के साथ जोड़ो. So all ecosystem is available in the one environment.
अच्छा चैतन्य सर, इसमें PMSM ब्लॉक है क्या? PMSM इंडक्शन मोटर 3 फेज.
Yes, sir.
All things there.
Just I will just show you.
Okay, sir.
आपको सर इलेक्ट्रिकल वायरिंग में, आपको इलेक्ट्रिकल कैड में जो चाहिए ना, वो सब इसमें है. दिस इज नॉट R&D टूल इन इलेक्ट्रिकल इंजीनियरिंग. जैसा आपको ईटैब है या आपको बाकी सॉफ्टवेयर है, ई प्लान है, तो
Yes.
ये सॉफ्टवेयर आपको इमीडिएट हैंड्स ऑन एक्सपीरियंस के लिए एकदम बेस्ट है. आपको मैटलैब में वर्चुअल इंस्ट्रूमेंट नहीं मिलेंगे, आपको वोल्ट मीटर नहीं मिलेगा, आपको CRO नहीं मिलेगा. इसमें आप ड्रैग ड्रॉप करके पूरा आपका इंस्ट्रूमेंट का कॉस्ट बचा सकते हो, आप गेजिंग का कॉस्ट बचा सकते हो, और आप बेसिक एक्सपेरिमेंट्स बहुत आराम से, बहुत इंटरेक्टिव वे से और बहुत एंजॉइंग वे से आप स्टूडेंट्स को पढ़ा सकते हो.
तो सर ईटेप और ई प्लान वो सब उसमें जो है, उससे ये अच्छा है क्या?
ये 10 गुना अच्छा है. मैं नहीं बोलता हूँ कि वो सॉफ्टवेयर अच्छा नहीं है, बट इसका जो पर्पस है और उसका जो पर्पस है पूरा अलग है. इसमें इंटरेक्शन बहुत ज्यादा अच्छा दिया है, उसमें R&D के लिए वो बहुत अच्छा है.
ओके सर, तो फिर हमें अगर एड ऑन कोर्स करवाना है फैकल्टी के लिए और स्टूडेंट्स के लिए, तो उसके लिए कुछ टीम है क्या जो इस पे हम लोग अगर करवाना चाहते हैं एड ऑन कोर्स, सर्टिफिकेट कोर्स फॉर?
हाँ, हमने क्या किया है सर, हम हार्डवेयर, इफ यू वांट, हम स्नाइडर का हार्डवेयर देते हैं और सॉफ्टवेयर हमारा देते हैं, सो दैट आपको अगर इफ यू हैव एग्जिस्टिंग 20 कंप्यूटर्स लैब, हम 20 कंप्यूटर्स में आपको 20 सॉफ्टवेयर दे देंगे, एक हार्डवेयर का दे देंगे, और बच्चे यहाँ पे सिमुलेशन लैब में उनका पूरा सिमुलेशन करेंगे और वो एक्चुअल हार्डवेयर में जाके वायरिंग करके देखेंगे. सो दिस हैज बिकम अ वेरी कॉम्प्लीमेंट्री स्ट्रक्चर, और उसको हम सर्टिफिकेट देंगे स्नाइडर का और ऑटोमेशन स्टूडियो का. तो बच्चों का कॉन्फिडेंस भी बढ़ेगा और उनको हैंड्स ऑन एक्सपेरिमेंट करने का, सिमुलेशन पे काम करने का, वो गलती होने का, गलती से सीखने का भी मौका मिलेगा. एक्चुअल मोटर पे आप गलती करके सीख नहीं सकते. आप आइदर शॉक लग के आपको एक्सीडेंट हो सकता है या आपका मोटर खराब हो सकता है. मेरा कंपनी का नाम सिमुलेटिंग सक्सेस है, SimuSoft है. मेरा कंपनी का नाम ही SimuSoft है. ये गरीब से गरीब बच्चा, कोर से कोर बच्चा कम प्राइस में सिमुलेशन टेक्नोलॉजी का यूज करके टेक्नोलॉजी सीखना चाहिए, ये मेरा मोटो है. इसीलिए आई एम क्लबिंग ऑल ग्रेट सिमुलेशन सॉफ्टवेयर so that students can immediately up in the skilling.
ठीक है सर, मैं एक्चुअली आपका नंबर इस पे है सर 9130842827. इस पे
सर वो बाद में कर सकते हैं आप.
हाँ, मैं आपसे सर कंसल्ट करके एक बार मैं एड ऑन कोर्स के लिए सर फैकल्टी.
यस एड ऑन कोर्स भी कर सकते हैं. हम स्नाइडर का कोर्स ले सकते हैं, आप पूरा PLC का इंडस्ट्रियल ऑटोमेशन का कोर्स लग सकते हैं, रोबोट का ले सकते हैं. वी आर देयर टू हेल्प यू. एनीवन एल्स प्लीज?
थैंक यू सर.
My point is not to promote my product. My point is to make you understand, do you really see the meaning of this in, because I want to understand what Chaitanya has explained you. Have you really understood it or not? After that, then I'll be able to explain you it in more detail. So can we go ahead? Yes, Chaitanya, please.
Okay, sir. So we have seen the electrical controls, the industrial control switches and all. Now in renewable, just left to show the windmill circuit. Only that thing has been left. And the question was from sir that we have the blocks of permanent magnet synchronous motors, right? So in both in generic and illustrator library, I have these both the blocks where uh, in its data or the parameters, I have all the parameters right from my rated voltage and all to my inductance, initial angular speed. I have to state stator resistance and all. Everything I can state or monitor also. Same for the illustrated motor too. Rated frequency, friction coefficient and all. And also the wind turbine or the wind generation technology. So what are the components required for that, and how does it works? If this also is very easy, because in electrician trade syllabus or in diploma, there we have the renewable energy connections and all. So to learn about that, how is the connection, the basic power flow, the types and all. See here in my lab from my renewable library, I've taken one wind turbine speed. Okay, then just a second. A, s- a generator, and here I have also the mechanical drive and transmission components. Like I have this tachometer, then I have a gearbox which is from 1 is to 200 or 1 is to 400 gearbox, or it will rotate. I have for braking system, I have NC shafts and all. Okay, I have connected here one resistive load to check the generation, how much energy is being generated. Now here I will just switch on my circuit breaker. Here we can see the energy generated at the end point. Okay, here we can see 0.28 kilowatt and all. But and I can change the wind speed, because for specific turbines, the basic we say that it is being limited speed, like more than 2 meter per second or 4 meter per second. The speed is there. Then only the turbine is or the windmill is being rotating. But the one rotation of wind turbine, we can change it in this gearbox system, that my one rotation can be converted into 250 4 times and all. So we can change it over here. Then what is the energy generated or the rotation at this point? See, then the my generator shaft is getting rotated. Then at this, from these points, my energy is getting. I'm getting my energy whatever I have. I have connected one resistive load and measuring drive. So as soon as I will increase my wind speed, my energy generation will also get increased. See, here it was from 0.85 to now 2.5, and it is even increasing. So different measuring part, part, so this was the demonstration of the only for electrical part, that just in electrical we have basic AC DC circuits, then the higher three-phase circuits, motor control or motor starter, VFDs, then renewable in we have here solar and all. So everything you are getting in one package in one software. You don't have to take separate solar kit. You don't have to take separately home wiring kit, electrical installation kit. Everything you are getting in one package, in one box, where students can learn them easily their own. The most important thing, which personally as an electrical engineer I can say, that this software allows us to do mistake and learn from them. Because initially, if I see this circuit which is on my screen right now, I will get confused or little bit scared that what is this? ये झमेला क्या है इसमें? अगर क्या करना है मुझे? कौन सा वायर कहाँ से जा रहा है? How there is a what is the series part, parallel part जो हम theory में सीखते हैं या फिर जो हमने देखा है. But actual जब हम hands on लेते हैं, the thing is when we do the hands on, then it will get fit on in our mind. And it is very safe and easy way to teach the electrical concepts and simulate, analyze, and design in Automation Studio software.
Great. Okay, Chaitanya, I think we can wind it up now.
Yes.
You have everything done
Yes.
with from your side?
Yes, sir.
Okay. So, thank you, participants. We will take your leave now. Anyone wants to share their feedback? Do you have any questions, please? You can unmute and now have a dialogue with us. Okay, thank you. I think we are done. Thank you very much. And then we'll be in touch. Thank you. Done? Thank you, Chaitanya.
Okay. Thank you, sir.